Welcome to the solution video of paper 52 of March 2022 of Cambridge International A-Level Probability and Statistics 1. Question number 1. A fair red spinner has edges 1, 2, 2, 3. Actually, it is not fair because of the 2 comes twice, but we'll count it once so that it becomes fair. Similarly, a blue spinner has this 4 outcomes. Each spinner is spun once and the number of the edges on each spinner lands is noted. Then random variable x denotes the sum of the resultants. Okay, now they're asking us to draw a probability distribution table for x. Before we do that, let me draw a table with outcomes and their combination. Okay, so there will be 4 down here and 4 columns. 1, 2, 3, and 4. Now, first we'll talk about the red spinner. Its outcomes are 1, 2, 2, and 3. The outcomes of the blue spinner are -3, -2, -1, and -1. Now, the actual outcome is the sum of the 2 outcomes, and this will be our playground. We will get our probabilities from here. So 1 plus -3 is -2, 1 minus 2 is -1. Now let's draw the probability distribution table. So x is the variable and the probability of x will be written here. What is the smallest outcome possible? -2. So let's start with -2, then we have -1, 0, 1 is there, 2, and there is no 3. Okay, these 5 outcomes are possible and there are 16 of them, right? So I counted 2 twice and -1 twice because we'll just count the number of outcomes they are giving and out of 16. So -2 is only once out of 16, so it will be, its probability will be 1 out of 16. Then we have -1. I can see 3 -1s, 1, 2, and 3. So 3 out of 16. 0 is 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. And 2, 1, 2 only, 2 out of 16. I'm not simplifying them because I want to add them and see if they're giving me 1. Every time probability distribution, probabilities must add up to 1. So 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 5 is 14, plus 2, 16 out of 16, which is 1. Very good. We have done the A part complete. Let's see what is the B part about. Given that expected value of x is 0.25, find the value of variance of x. There was no need to give expected value, but I think they want us to save some time, so we can accept it. We could have calculated it, yeah, but they've given it, good. Now, we have to find variance. The formula for variance is given in your exam, sigma x square multiplied by its probability minus expected value square. So each x will be squared first, then multiply with its own probability. This px is actually p. Then we will add all of them and then subtract this. Let's do it in one go. Okay. So let me square -2 first, which is the first x, multiply with its probability 1/16, plus second x is -1 squared, its probability is 3/16, plus 0 square, I'm not writing it because 0 square will be 0 and multiplied will be 0, so I'm straight away going to 1. 1 square, the probability is 5/16, plus 2 square, probability is 2/16. Okay, this is done and we will subtract the expected value 1/4 square. I'm not simplifying all of them because all of them have denominator 16, which will make us calculate easier. So 4 times 1/16 becomes 4/16 Positive, right? Because it is squared. Negative is squared. 1 times 3/16 would be 3/16. Then 1 times 5/16 is 5/16. 2 times 2 is 4 times 2 is 8. 8/16 minus 1/16. This is 1/16, okay? And since all of them have 16, we can easily deal with the numerators only. 4 plus 3 is 7, 15 plus 8. 4 plus 3 is 7, plus 5 12, plus 8 20, minus 1 19 over 16. This is the variance. If you want to convert it to decimal, you can convert, which is 1.1875. That's the variance. Let's move on to the next question. In a certain country, the probability of more than 10 centimeter of rain on any particular day is 0.18 independently of the weather. Okay. Find the probability that in any randomly chosen 7-day period, one 7-day period, right? More than 2 days have 10 centimeter or more rain. So it seems to be binomial distribution. We have 4 conditions. Are the events independent? They have mentioned that all days are independent, right? So then we should have a clear success and failure. Yes, we have, because it will rain or it will not rain more than 10 centimeter. So success failure is there. Probability should be constant. Yes, it is 0.8 throughout. And finally, the total number of selections should be finite. Total. We have 7 days. So it's fixed. All 4 conditions are there, so we can use binomial distribution in this one. Now they're saying more than 2 days have more than 10 centimeter of rain. Don't involve this 10 centimeter anywhere, because it is just a statement, more than 10 centimeter of rain. I think it is here also more than 10 centimeter of rain, so we don't have to worry about it. So we want success on more than 2 days. Okay, so which will be 3 is more than 2, x equal to 3, or x is equal to 4, or x is equal to 5, x is equal to 6, and x is equal to 7. That is more than 2. But there are how many? 1, 2, 3, 4, 5 conditions. I don't want to do this. We can do rather, because what is missing in this? 0, 1 and 2 are missing, isn't it? Then we have 3, 4, 5, 6, 7 all here. Let's find probability of 0, 1 and 2 and subtract from 1. So probability of x equal to 0 plus probability of x equal to 1 plus probability is x equal to 2, and subtract them from 1, we'll get these 5 of them. So we have to interpret them into probabilities now. This one first. When we have 0 successes, we write total number C0. Then success, the probability of success is 0.18. No success we want. We want all failures. 1 minus 0.18. So 1 minus 0.18 will be the failures probability, which is 0.82. So 0.82, all 7 days, there is no rain more than 10 centimeters. Then 7C1 for this one, 0.18 to the power 1, and no rain more than 10 centimeters on 6 days. 6 plus 1, 7 days. Then 7C2, 0.18, 2 days success, 5 days failure. And now just evaluate them one by one or together, is your wish. I would recommend that do it one by one. So the first one I get 0.249285. 0.249285. Now for this one I get 0.8, 0.38, 0.383048. And then we get 0.25225. and then subtract, we get almost 0.115. This is the probability that more than 2 days out of 7 it will be raining 10 centimeters or more. Okay, B part. For 3 randomly chosen 7-day periods. Earlier we had only one 7-day. Now we have 7 days, again some other 7 days, and some other 7 days. Period. Find the probability that exactly any two of these periods have at least one day with more than 10 centimeter of rain. At least one day each one. So that means let's focus on only one first and find the probability of rain of more than 10 centimeters on at least one day, which means x is greater than equal to 1 this time. Okay, at least 1, 2, 3, 4, 5, 6, 7, but that will make it 7. Why should I do that? Let me do it. Probability, rather not probability straight away. First, 1 minus probability of x equal to 0, isn't it? Out of this, at least one, only one case is out, which is that x is 0. Otherwise, 1, 2, 3, 4, 5, 6, 7, all are here. I don't want to write it 7 times, just write once and subtract from 1 again. So I will find probability for each one that at least one day it rains more than 10 centimeters. So 1 minus 7C0, 0.180 and 0.82 to the power 7, and we already got it in previous part, which was 249285. Okay, which is 1 minus 0.249285. Okay, let's write it, subtract it rather now, which will be 0.750715. Okay, so but we don't want such a big answer, so we round it off to 0.7507. That is the probability that at least one day it rains more than 10 centimeters. But they said one of the, rather exactly two of the 3 days, 3 sets of 7 days, it rains like this. Again, a binomial distribution here. We have the same 4 conditions meeting. We have fixed number 3. They want exactly, let me use y this time, y equal to 2, exactly 2, no more, no less. 3C2, the success is this now, that it rains at least one day, it rains more than this. Not success, we want 2 days. And failure was, let me write 2493. 2493, 0.2493 to the power 1. So 1 week it does not rain more than 10 centimeters at least one day. 2 weeks it does. And this is what I will put in my calculator. When I do this, I get 0.421469. And I have to round it off again. So answer is 0.421. This is the probability. What's next? Okay, at a summer camp, an arithmetic test is taken by 250 children. Okay, the time taken to the nearest minute to complete the test was recorded. Okay, the result are summarized in this table. Draw a histogram for this. Okay, for histogram, I need something. Okay, this is the number of time, right? Time taken in minutes. So this is time, and on this we need frequency density. Why? If you look at the groups, it is for 30 seconds or minutes, 30 minutes. This is for just 15 minutes. Then we have this one for 20 minutes. So that's why we need to make this. So Since there is a difference between 30 and 31, we will close this gap by writing 30.5, and we will write 0.5 at the lower limit. So it becomes 0.5 to 30.5, the other one becomes 30.5 to 45.5. So everyone will be, the gap will be closed. But when we calculate the frequency density, we use just 30 of them because 1 and 30 both are included. So 30.5 minus 0.5 will be 30. So class width, let's write here, class width is 30. Here it will be 15. Here 20. And then 10 and 25. I hope you understand. Let me give an example of the last one. It becomes 100.5 and it starts at 75.5. If you subtract 100.5 minus 75.5, it is 25. That's how we find class width. Now, density will be 21 divided by 30. The frequency divided by class width. That is the frequency density, which is 0.7 in this case. Okay, here it will be 30 divided by 15, which is 2. Here 68 divided by 20 is 3.4. 86 divided by 10, 8.6. And 45 divided by 25 will be 1.8. So we will mark up these now. We have the highest 8.6 density and lowest is 0.7. So we will start with 0 again, and we have to reach up to 9 because 8.6 is the highest. So let's write here 1, 2, 3, 4, 5, 6, 7, 8, and there will be 9 there. Okay, so the first bar will be 0.7 units tall and width is 30, from almost 0 to 30.5. Let me change the units to 0.5s again so that it becomes easy to draw it. So I will add 0.5 to the units. Done. And now I will write 0.7, which is almost here. 0.7 is from 0 to 30.5. This is the height of the first bar, which you can shade if you want, right? And like this, I will complete the whole of the table. So the second one. And it is finished. This is how it will look like. You need to take care that you mention the labeling of the axis. Okay, what next? State which class interval contains the median. So total, how many are they? We'll have to see 250. Half of 250 is 125. Yes, 250 divided by 2 is 125. We have to see the cumulative frequency. Where do we get 125? So let me write on top cumulative frequency. First one is 21. That is the frequency of the first one. Then we add 21 and 30. 51. Then 51 and 68 will be 119. 119 plus 86 will be 205. So we wanted 125. It is more than 119. That means this is where 125th data will be here, which is 66 to 75 here, but we will not write 66 to 75. We will write 65.5 to 75.5. That was our new interval, and that's what we will write here. It's just for 1 mark. Okay. Given that an estimate of the mean time is 61.05 estimate, okay? All right, state what feature of the distribution accounts for the median and mean being different. 61.05 is less than 65.5. That means it is in the lower interval, right? They are different. That's the question they're asking. Why this difference is there? So we can say the difference is because you can see the groups are uneven, and their frequency are also very uneven. Can you see 86 here, just 20, 130 here? So we can write the reason for being median and mean being different is that the data is uneven in class distribution and frequency. That's the reason median and mean are different. Next question is this. The weights of male leopards in particular region are normally distributed. The mean is 55. So let's visualize. This is the distribution. The mean is 55. Standard deviation is 6 kg. Find the probability that the randomly chosen male leopard from this region weighs between 46, so 46 will be less than 55 somewhere here, and 62, which is more than 55. How less is this? 9 less, and this is 7 more. So they are not equal. They are not equally distant from mean. So this is the area under curve. We have to find the total probabilities here. So what my plan is that I will find the Z score for 62, which will be 62 and less, the whole area, this one. Then I will find Z score for 46, which will be negative obviously because it is less than 55, which will be this blank area. And from this total area under 62, I will subtract the area under 46 and I will be left with this area. So let's find the Z score for X is less than 62, which will be 62 minus mean 55 divided by standard deviation 6, which is 7 out of 6, yeah, 1.166. And now let me use the normal distribution table. I'm not sure during editing how much will come on your screen, but yeah, I'm trying to show it to you. 1.1 is here and 6 will be, which column? This one. Here it is, 8770, 1.16, and I need 6 more, which is here 14. So I will write 0.8770 plus 14, which is 8784. 0.8784 is the probability if x is less than 62. 0.8784. Z score for x less than 46 will be 46 minus 55 over 6. So 46 minus 50 minus 9 over 6, which is negative 1.5. The Z score is negative 1.5. We don't have any negative 1.5 in our this chart. So what we'll do, we'll find our 1.5 positive, which is 0.9332. Okay, 0.9332. We will use it here, but we can't use it purely here because the Z score is negative. So probability of x less than 46 will be 1 minus 0.9332. So whenever we have a negative Z score, we subtract the probability of the positive counterpart of it from 1, which will be 0.668, right? 0.0688, right? 0688. Okay, so now our plan was to subtract the probability of 46 from probability of 62 and less. So probability that x lies between 46 and 62 is 0.8784 minus 0.0668. So it will be 6118. 0.8116, or if you want to round it off, 0.812. We have the next one. The weights of female leopards in this region are normally distributed with 42 mean. So again, we have normal distribution. Mean is 42 kg. And standard deviation. We don't know how much is that. It is known that 25% of the female leopards in the region weigh less than 36. This is the area which is 1/4, 0.25 or 25%. Okay, and this is 36 kg. Alright, find the value of sigma. Alright, so we know that z score for x is less than 36 will be 36 minus 42 over sigma, right? And now we need to go back to our chart and see what is the area, what is the counterpart of 0.25 in the chart. 0.25 is nowhere to be seen, and rightly so, because there is no negative z score, so we can't find 0.25 here. So what will we do? We'll find rather the blank area, which is 1 minus 0.25, and find z score for 0.75 probability, and then put a negative in front because it will be the reflection of what we want. Okay, so 0.75. Let's go back to our chart and see here 0.67. So 0.7486, we need 14 more. 14 is nowhere, so that means it will be between 4 and 5. Let's say 4. So 0.674. So 0.674 was the z score for 0.75, but we wanted for 0.25, which will put a negative in front, and that becomes the z score. So 36 minus 42 is minus 6 over sigma, equal to minus 0.674. So sigma and 674 exchange their places. It becomes minus 6 over minus 0.674 equal to sigma, negative and negative cancel, and 6 divided by 0.674 we'll find through our calculator. By the time I do this, I request you to subscribe to my channel, like this video, share with your friends. Perhaps I'm the first person in the world to answer this particular paper, and if you subscribe, I'll be motivated to make more videos like this for you. Thank you. And what I got is 8.90. This is the standard deviation. Let's see what is in the next part, which is C. Find the probability. Okay, first, the distributions of the weights of male and female leopards are independent of each other. Okay, we have drawn the distribution for them already. A male leopard and a female leopard are each chosen at random. Find the probability that both the weights of these leopards are less than 46, both. So we have to find probability that male leopard, let's call it M, is less than 46, and probability that female is also less than 46. So we will multiply their probability because there's an and they are independent. So when the events are independent, we can multiply them. Let's see if we have 46 already in our previous parts. Yes, we have here. The probability that it was less than 46 was 0.0668, 0.0668 multiplied by female less than 46. Do we have it here? No, we don't have it here. So we'll have to find it, and let's do it here. First, we have to find z score for female being less than 46. I changed the variable x to f, okay? Doesn't matter. 46, the mean is 42. Now we know the standard deviation is 8.9. Let's see, it will be 4 over 8.9, which is 0.44 494. For Z score, the fourth digit is useless, 0.449. So let's go back to our table and see 0.44, 0.67, and 9 is 32. So 6732. 6732. The probability that that was Z score, okay? Female is less than 46 is 0.6732. So here we will write 0.6732. And now these two probabilities we have to multiply, and I get 0.04496. And three significant figures we can write it as 0.0450. This is the probability that both of them weigh less than 46 kilograms. Here is the question number 5. A group of 12 people consists of 3 boys, 4 girls and 5 adults. In how many ways can a team of 5 people be chosen? 5 we have to choose from the group if exactly one adult is included. So out of 5 adults, we have to choose 1. And then there are total 5. So remaining 4 will be chosen from the remaining how many? 7 people. This will be the solution. Let's see what it is, which is 175 selections. That's straightforward. B part. In how many ways can a team of 5 people be chosen from the group if the team includes at least 2 boys? Okay, so there will be some boys, there will be some girls, and there will be some adults. So at least 2 boys and 1 girl have to be there, right? So how many adults will be there in this case? 2. That's how it becomes 5. Next, it remains 2, but girls become 2. So it becomes how many? 4 and then 1 adult. Have we talked anything about adults? No. That means it is possible that the boys are still remain 2 but girls become 3 and there is no adult. Then we can have 3 boys and then 1 girl, right? And 1 adult. Then we can have 3 boys, 2 girls and no adult. Okay, these are the 5 selections possible. Let's interpret them into the process of selection. The boys are 3 boys. We have to select 2 of them. 3C2 multiplied by, out of 4 girls, we have to select 1 girl, 4C1. Then we have 5 adults and we have to select 2 of them. And now let's evaluate them, which I have done already. 120, 90, 12, 20 and just 6. So if we add these, we get 248 such selections. Next part. The same group of 12 people stand in a line, okay? How many different arrangements are there in which 3 boys stand together and an adult is at each end of the line? Which adult, specific adult, they have not said. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is taken by any adult. This is also taken by any adult. That means we have to select these 2 adults out of those 5. Any 2 can stand here. So we will select them by 5C2 process. These 2 adults can change their position with each other. So 2 factorial ways. Second condition is that all 3 boys, there are 3 boys, 4 girls and 5 adults, 3 boys, all of them have to be together. Let's say they are here. They become one box and they occupy 3 places, but we will count them as 1. So these 3 boys, B1, B2 and B3, they can change their places with each other also. So we'll have 3 factorial in this box, right? But now this box will move with each other only. The 3 will be counted as 1. So how many are there now? 1, 2, 3. This is fourth, 5, 6, 7, 8. These 8 places can be interchanged. So we will put 8 factorial here as well. In place of 5c2 2 factorial, you could have written 5p2 also. Means your solution can also be 5p2 times 3 factorial times 8 factorial. Both of them will give you the same answer. And they come out to be 4838400 arrangements possible. Question 6. A factory produces chocolates in 3 flavors, lemon, orange and strawberry, in a ratio of 3:5:7. Okay, respectively. Nell checks the chocolates on the production line by choosing chocolates randomly one at a time. Find the probability that the first chocolate with lemon flavor that Nell chooses is the 7th chocolate that she checks. Okay, so that means if the 7th one is a success, first of all, what is the probability of a lemon flavor? So lemon is this one, right? 3 out of total how many units? 8 plus 7, 15, which is 1 over 5. Yeah. All right. So this is geometric distribution where 6 times she fails. So 1/5. This is the success. But before that, what is failure? Failure will be 1. The probability of failure. Probability of failure is 1 minus 1/5, which is 4/5. So this is the 7th time success. That means before this 4 over 5, this 6 times she fails. Unlike binomial distribution, we will not write here 6c some or 7c6 because it is confirmed. The position of the failure is confirmed. Position of the success is confirmed. It is 7th only. So we don't have to write anything before this. Just put this in a calculator and you will get the probability of this. What I'm getting is 0.0524. B part. Find the probability that the first chocolate with lemon flavor that Nell chooses is after she had checked at least 6 chocolate. She has checked 6 chocolate. That means the success of getting a lemon flavor, lemon flavor, is 7th onwards. It could be 7th, it could be 8th, it could be 9th, it could be 500th, or so on. That is, we are not sure which one after this, but what we are sure is that 6 times she doesn't get lemon flavor. That means she fails 6 times, and after that success, she certainly gets success. Which number, we don't know. Just put this and you get the answer. What I get here is almost 0.262. Part C. Surprise boxes of chocolates each contain 15 chocolates, 3 lemon, 5 orange and 7 strawberry. Total 10 plus 5, 15. Petra has a box of surprise chocolates. She has a box which has these 3 things. She chooses 3 chocolates at random from the box. She eats each chocolate before choosing the next one. What they are trying to tell you that it is without replacement. She eats, that means it can't go back into the box. Find the probability that none of Petra's 3 chocolates have orange flavor. So probability that it is not orange, that means O prime. Then again, probability that O prime and probability of O prime, and they happen one after another. So and means they are multiplying, right? Let's see. First chocolate she chooses, there are 15 of them, and how many of them are orange? 5. We don't want those 5. That means remaining 10 out of 15 will be giving us the probability of orange in first. Second, she has eaten one of these 10. So now we are left with 9 out of 14 because she has eaten one. Now there are only 14 chocolates in the box. And then it will be 8 because she's again eaten the one which is not orange. So it will be 8 out of 13. These are the 3 probabilities you multiply, and what I get is 0.264. That's it.